Okay.
10. Oh yeah, you're right.
Let's just go over some examples of this, and I'm gonna sort of review the properties as we go. So like, just getting into it here. This first question. 1A.
Times 2 because double-sided is 4. Changes. 6. I was closer.
No solution? No, there's a solution.
You know, you were actually saying.
Right, it's not an equation. It just says simplify the expression. So the idea here is you're given an expression. So simplify has a meaning. It means write this. Now, here's the thing. It's not, something that's not super cut and dry. What is the most simplified? But you just use your best judgment and say, you're typically looking to express it in fewer symbols. Okay, that's a lot of symbols there that we have to use to express that. So what you do is you say, well, first of all, how does this work? Well, if you squared this, now in your head you might be thinking of this as being x times x times x times x times x, 5 x's and 3 y's. So if you square that, right? So now imagine a second copy of that next to it. How many x's would there be? There'd be 10. How many y's would there be? 6. So step 1 is this guy turns into x to the 10th, y to the 6th. Now there's sort of like a moral to that story, if you think about it, which is if you've got, say, a times b to the n power, you guys have all heard of the distributive property, right?
Yeah. That's where you drop your kids.
It's what you do what?
When you drop your kids off at daycare, you distribute them. You know?
Yeah.
That just not immediately came to mind?
No, distributive property, what I mean is like, okay, so if you have a plus b and you multiply that by n, you get n times a plus
Yeah,
n
but-
times b. That's multiplication distributing over addition. But you can also have a times b to the n power, and you end up with a to the n power times b to the n power. That's called, it's a similar idea, but it's the exponentiation distributing over multiplication. So in math, you have this type of operation sometimes can distribute over a different operation. Does that make sense? Okay, so anyway, let's combine. Okay, so now multiplication is commutative, so I can go, well, I mean, I could write it out. It's not really necessary to show this step, but suppose you did. Everyone understand that?
Mm-hmm.
So what's x to the 4th times x to the 10th?
14.
The 14th,
Mm-hmm.
No, it's fine. I got it.
right? So yes, imagine 4 x's, right? This is x times x times x times x, and then right next to that would be a string of 10 x's, so you'd have 14 total.
Right.
Okay, so what that tells you, the moral of that story is, if you have, generally speaking, if you have x to the a power times x to the b power, that's x to the a plus b power, right? So the exponents add up in that case. Does that ring a bell?
Yep.
You sure?
Yes.
Okay. Unfortunately. Think of all the extra TikToks you could fit into your mind if that it wasn't clogged up with that extraneous information. All right. B. Okay. First thing you got to do. Let's square that binomial, right? Hopefully you remember how to square a binomial. So you're gonna have x. Now here's a question. Just a good chance to use our fancy smart brain knowledge. Does exponentiation distribute over addition? No, it does not. You can't just go that squared plus that squared. What you're gonna end up with is x squared plus 2 x to the Have I lost you?
Yes. Third.
Okay, so
Sorry.
remember, generally speaking, a plus b squared gets you a squared plus 2 times ab plus b squared. So you see what I'm doing here? I square the first guy, applying this idea. So x squared plus double their product. What's this times this? X to the 4th. Then what's that squared? Good. So let's review that super quick. Oh yeah, if you have an x to a power raised to a power, what do the exponents do? They multiply, right? So generally speaking, x to the a raised to the b power is x to the a times b power. Does that ring a bell? And then just think, why is that? Why do they multiply? Well, think about what it means to say x cubed squared. Why do we end up with 6 x's and not 5? Well, x cubed looks like this. And if you square that, you have 2 copies of it. So that's why they multiply, right? Make sense? Okay, this whole thing is being divided by x though. So how many of those terms are being divided by x? All of them. Here's another intermediate step that you probably don't have to write, but if you're, maybe just hopefully to avoid confusion, what this looks like is x squared gets divided by x. The 2x to the 4 also gets divided by x. And the x to the 6th gets divided by x. So what's this first thing going to be? X. What's this going to leave? 2x to the 3rd. And how about the last one?
5.
X to the 5th. Does that make sense why you're subtracting the exponents? So in general, if you have x to the a divided by x to the b, you get x to the a minus b. You subtract the exponents. Do you feel okay about that? Okay. We sure there's no questions?
All I see is
All you see is x? I don't understand that one.
You really spent too much time.
It's that there's lots of X's on the board and it's all confused.
Thank you.
I can make them all
Great
like
explanation.
smiley faces if you want.
Yes, please.
Give me any symbol you want.
Smiley face.
Okay, we'll do C.
Yeah.
C using the superior symbol of smiley face.
Yes.
Okay, so 3 smiley faces
Yeah.
multiplied by 4 smiley faces to the 5th power minus 2 smiley faces.
Whoa, math is fun.
Divided.
This has changed my whole perspective.
That's better.
Yeah.
Wow, look, oh my
Aiden, you're a
goodness.
genius.
Wow, so much better. So much more interesting. So we have to use, we have to distribute that multiplication over the addition, or the subtraction, I should say. So 3x times 4x to the 5th makes 12 smiley face to the 6th. And then this times this makes 6 smiley to the 2nd. And the whole thing is divided by. Now, one a very common mistake that students like to make, well, they don't like to make it, they just make it, they tend to make it, is they see that and they just cancel it right out. But we know that's not how division works. Hopefully we know that.
I did not.
Both of these terms are divided. There's a subtraction sign there. So they both have to get divided. So what's that divided by that? What's left over if you divide that by that?
12 smashes to the 4th.
It's the 4th. So remember, when you're dividing 2 powers like this, you end up subtracting the exponents. Okay? And why is that? Well, if you had a row of 6 smiley faces and underneath that was a row of 2, you'd cancel out 2 pairs and you'd have 4 left. 6 minus 2. What's that divided by that? We're done. Now it's simplified, right? Surely you agree that this is a simpler way of writing this.
Wow.
All I see is smiley face.
Change the symbol every.
Let's move on.
Yeah.
D. What? What do you want?
Cupcakes.
Cupcakes?
We're just people.
Can you add the little sprinkles too?
Wow, that's really
I think
good.
that looks more like a muffin.
I mean, I wouldn't
I'm
take.
gonna need some frosting.
I wouldn't mind a muffin either. Truth be told. Charles so done with us.
There you go. So,
Oh my god, that just got pulled out of it. Okay.
what should we do first? I wouldn't use the word distribute just because this exponent cannot distribute over the addition. If these had been multiplied like this, then you could do that, but we have to square this bottom here. We have to square that just like this. So that's going to give me, what's cupcake cubed squared?
Cupcake to the 6th power.
Cupcake to the 6th power
Oh my god.
plus
Speaking in
2
Two.
cupcake to the, right, that
Eight.
times that, 3 and 5 makes 8.
I thought 3 times 2 is 9.
And then,
I wrote it down wrong.
so keep in mind, guys, these are like, I mean, if they're easy for you, that's good. That's great. But if not, like, just keep in mind, they're not, there's a lot to keep track of. Like, it's a lot to keep track of at once that, like, for example, you can't distribute the exponent over the addition. And that when you multiply these, you add the exponents, but when you square this, you multiply. Like, that's a lot to kind of keep straight. So just be patient. So now the top is cupcake to the 10. Again, what is the student often tempted to do?
Oh, cancel out.
That is not how division works. That's not correct, right? Why not? Works. That's not correct, right? Why not? It's worth pointing out. I mean,
Why? Why can't?
a good counterexample is
10
like,
cupcake?
if you have 3 over 5 plus 3, that's 3/8. But if you just cancel out
No,
the
it's
3s, you
1/5.
end up with
It's 1/5.
1/5.
150.
I'm not sure exactly what you think you'd end up with if you could do that, but
150.
1/5 or 1/6 maybe. But anyway, so what I got to do is say, what's the common factor on the bottom here?
Cupcakes.
Cupcake to the
Is
6th, right? Because this thing is this thing. Okay, so here, let's just see how it looks. So you got cupcake to the 6th, and I factor it out. What's left over? 1, right? Cupcake to the 6th times 1 gives me cupcake to the 6th. And here, 2. What number goes here? What exponent?
2.
To the 2, right? Because c to the 6th times c to the 2 makes c to the 8th. And then the last one would be
4.
4th power.
Francis.
I'm not gonna talk to this.
So what do you think we're going to do in the top one to make this? We're seeking out the spice of life. Cancely wancelies. Yeah, take out cupcake to the 6th from the top. So if I factor the top, what's this guy? What's his power?
4.
4. Now, this is how multiplication and division work, which is, to give you an example, a simple one is 3 times 5 divided by 3 times 7 is the same as 5/7. So I can now, because now it's multiplication I'm dealing with. So my final answer to this is cupcake to the 4th over the quantity 1 plus 2 cupcake. God, drawing these cupcakes is a pain.
And they don't.
Let's go back
Yeah.
to muffins.
That is a muffin.
It's not.
What's the cupcake? We need a muffin.
How would you make a muffin and a cupcake look differently?
Frosting. Cupcakes have frosting.
Well, but
Hear me
that's
out,
a fruit, a cupcake.
All right, let's keep going.
Cupcakes don't roast it.
Yes, Julia.
You typically like frosting, but
And this
make it
is
before
a muffin. Right.
I'm scared.
Very important.
You're really gonna stab me.
Not bad.
This one's not too bad, right? Now we have a few options here. We could just deal with the thing inside the parentheses first. That's one approach.
You like that one?
So if you're at all confused by this, what I'd recommend is, especially with the small numbers, is just draw it out and you'll see what happens. Jaden, get away. X cubed is x times x times x. So the top is x, 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 y. The bottom is x, y, y, y. The whole thing is still squared, right?
Right.
So let's try, now it's all multiplication and it's all multiplication, so I can cancel Ebobanzel. One pair of x's goes away, bye-bye. And one pair of y's goes away. So now, what's left over?
X squared over Y squared
X
squared.
squared over y squared, squared. What, now when you square this, suppose you find yourself confused in the situation, you could say, well, I know what squaring means. Squaring means to multiply the thing by itself. So what's going to happen if you have x squared over y squared multiplied by x squared over y squared? What's the top going to be?
X4,
X to the fourth
Y to the fourth.
over y to the fourth. There you go. What's wrong, Zarita?
I am saying this is
Oh.
amazing. Actually, Asiana, I wasn't saying it, I was just saying, this is what I need. I'm talking about how it's X's and not cupcakes anymore.
Rip Veronica. Okay, now there you go. As far as like getting, just quickly touching on the whole simplify idea, you know, if you write this, are you wrong? No, you're not always right. That's certainly not true. But this, so you could argue that this is simplified. They're both would be fine, acceptable answers. Okay. Let's do one or two more.
You know what triggers me?
What triggers Julia?
The fact that people consider spaces to be characters. There's nothing there.
What did you say? What?
Oh, yeah,
It's not a character if there's nothing there.
Yeah.
There is something there. There's a space.
No, there's nothing there.
Oh my god, I thought we were talking about like in a movie.
It doesn't make any sense because there's
I
nothing
was just
there.
talking
A
about outer
character
space.
indicates that there's something, but a space is nothing. It's just a space.
But space is a character.
There's nothing though. It's not
But, like,
space. You have to put the button for it.
If there was
It's a
nothing
space.
there, then there would be nothing to separate them.
Okay, we broke something.
Every character is encoded, you know, digitally. The space has its own code.
Yeah.
A space takes up memory in the computer. Are you talking about a
My
computer
favorite
or like
type
just
of percussion
writing?
instrument.
Well, I guess it goes.
Cranium.
But for
You
writing,
You need to carry the cable all the way down into coordinating.
Right, I've just never heard anyone talking about character count on like a handwritten thing. I've only heard it in the context of a like digital document, in which case every space, that's a piece of data.
I guess that's a valid argument. It's still.
You're being judged on how many characters you're
Yeah, are you doing a college essay that says like a character count?
No, it was a scholarship essay, and I did it, but I didn't count the spaces as characters, so it was way over.
You went and hand counted the characters? The computer should tell you how many characters there
Oh
are.
my God.
My computer, for some reason, it doesn't count spaces as characters, right? But when I brought it into the school and used the internet character counter, it counted the spaces.
Oh.
But there's also a thing, it's like character count without spaces and then character count with spaces. You can choose either option.
Okay.
I'm not
Sorry.
gonna be able to do one of these problems.
Okay. Can we use the distributive property to distribute this multiplication over this addition?
No.
Yes, yes.
I thought you could do it with adding.
Well, so like, think back to basics, right? If I have 3 times x plus 5,
Oh,
can I distribute that 3 in?
Yes.
All I'm trying to show you guys here is that there's another distributive property that doesn't get mentioned very often, which is that, like if I have, again, like a times b to the 3rd power, that's the same as a to the 3rd times b to the 3rd. So in a very real sense, the exponent distributed over the multiplication. So, okay, what are you gonna get if you have this times this?
X negative 6 to the power.
X, no,
And negative 1.
you gotta add the exponents. X to the negative 1.
No.
You getting on this, Sarita?
I'm wrong. No.
How about this times this?
0.
X to the 0 power. Now,
That's 1.
yeah, so there's a couple things here. Is there a nicer way of writing x to the negative 1 power?
Yes.
1
1
over
over
x.
X plus 1.
1 over x. How about x to the 0 power?
Plus 1.
Oh.
1.
Wait, can you go back?
So generally speaking, any negative exponent, okay?
No.
If I have x to the negative n power, that's equivalent to 1 over x. Exponent does, right? Everyone's familiar with this, right?
Yeah.
You all seen this before?
Yes.
Okay, so that we use that fact to deal with this. And it's also true that really anything to the 0 power is 1. And I'll give you a quick little, who actually knows a good reason for why that's true?
Just for fun.
Just for fun. No, it actually makes really good logical sense. So I'll give you an example here. Let's do powers of 2. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. You get the idea. What if we go backward?
1.
What's next?
1.
Okay, so 2 to the 0 must be 1.
Then
you can
it's
repeat
1/2.
that
1 or 2, well,
argument. Oh yeah, if you keep the pattern going, yeah, what's 2 to the negative 1? 2 to the negative 1 would be 1/2. 2 to the negative 2 is 1/4, and so on and so forth. Right.
Yeah.
What's really interesting though, the weird one is 0 to the 0, which we typically say is just, we let it be 1 just by definition. But because 0 to any non-zero power is 0, but there's a special case where 0 to the 0 is 1, and
0 times.
they, capital T, they, just choose to define it that way because it makes a few famous formulas work out nicer. So
It makes math work nicer. But
No one
support
needs
my
to make